What amount must be invested today to provide for quarterly payments of $3,500 at the end of every quarter for 15 years after a 5-year deferral period? Let's assume that the funds are going to earn 5% compounded semi-annually. Let's try to break this question down into two parts. In the first part, we're going to try to calculate the present value of our 15-year annuity. Looking at the structure of this annuity, we know that payments are happening at the end of every quarter. So our payment frequency is 4. Payments are coming to us of $3,500. We know that our future value at the end of the 15-year period should be $0. And if we take our quarterly payments and multiply by 15 years, that tells us that n is equal to 60. We're going to assume here that funds are earning 5%, compounding semi-annually. Our goal is to calculate that PV value. All right, so ensuring that our calculator is set into end mode, let's go ahead and start inputting some of our values. So here n is equal to 60. Our interest rate is 5%. Let's go into the submenu. My PY is already 4, but I'm going to scroll down. I need to update my CY to 2. Quit the submenu. I'm going to program in our payment size of $3,500 and our future value of 0. Let's go ahead and compute that principal amount. And so the calculator tells us that the principal amount of that annuity is going to be $147,422.10. That's 5 years from today because we've gone through this 5-year deferral period. And that brings us into step 2, where we now actually have to discount that money 5 years to calculate the fair market value today, or the fair market value before that deferral period. And the easiest way to do that is to apply the principal amount or present value formula for compound interest. So let's take the PV that we calculated in part 1. I'm going to alter it so that it's a positive value here, and we're going to discount it by using 5% compounded semi-annually. And if we have a 5-year deferral period with semi-annual compounding, that means that n is equal to 10. And simplifying this expression, we should get $115,165.91.